Graphing an exponential function. To graph an exponential function, you first have to have a function, and then you have to make a table with values, and then you plot them on a graph to create your exponential graph.
Okay, so now we're identifying if the graph is going to be an exponential growth or decay. So to first start finding if it's going to be a growth or decay, you want to find b and see if b is greater than 1, it will be a growth, like this. And if it's greater than 0 but less than 1, it will be a decay. So now we're going to be modeling exponential growth. And so this is the problem we have. Sarah invested $2,000 in a savings account. The account pays 5% annual interest. How much money will be in Sarah's account after 8 years? So this is the equation we're going to be plugging everything into. It's a times t equals a times 1 plus the annual interest to the number of years. So t is the number of years since money was invested. A to the t is the amount in the account after each year. So if we plug everything all in together, we'll get a of 8 equals $2,000 times 1 plus 0.05 to the power of 8, because the 5 would be the percent and the 8 would be the amount of years. $2,000 is the amount. So if we do all the math together and we combine all the terms, it would be $2,954.91.
Go.
So now we're using exponential growth to find a certain amount of money. So the question is, Sarah invested $2,000 in her savings account. The account pays 5% annual interest. If she makes no additional deposits or withdrawals, how much many years will it take for her account to reach $3,500? So this is what we could find out with exponential growth, because we have the base $2,000 and the 1 plus the 0.05%, that's the percent. So we just plug in a different number of years to find when she will reach 3,500. So if you plug in 7, you will get 2,814. So you can see that all through the line until she plug in 12 and she'll get $3,591.71.
Okay, so our goal is to write an exponential growth function in the format of a of t is equal to a times 1 plus r to the t. And our example problem is Sarah invested $2,000 in a savings account. The account pays 5% annual interest. How much money will be in the account after 8 years? T is equal to time, r equals rate, a of t is equal to the total, and a is the starting value. So within the equation, we find that $2,000 is the starting value, 5% is the rate, and 8 years is the amount of time. So we plug this into the equation where so the equation will read a of t is equal to 2,000 times 1 plus 0.05 to the 8th. Go.
Okay, class, welcome to school. Let's get started. Okay, so today we're going to be learning about graphing exponential graphs. Graphing y equals ab to the power of x. So this is our example. The graph to f of x equals 2 to the power of x. Now this 2 is going to be b because there's no a. And because this b is greater than 1, the exponential graph goes up. So if we plug in these x's to the power of x, this is what we'll get to make the graph an exponential graph.
So now we're translating the parent function y equals b to the x. So you start off with your parent function y equals b to the x, which is the dashed line. And then to translate the line to the left, you add a number to the exponent. For example, y equals b to the x plus c would shift it over here. And y equals b to the x minus c, this line would shift the graph to the right. Using an exponential model, the example we'll use today is graphing y equals negative 1/4 times 2 to the x. First, we'll choose several values of x and generate ordered pairs. So we'll make a table of values as seen over here. So for the x values, we have negative 1, 0, 1, and 2. And for the y values, we have negative 0.125, 0, negative 0.25, negative 0.5, and negative 1. Then we will graph the ordered pairs and connect with a curve. So over here is negative 1, negative 0.125, and then this is 0, negative 0.25 because it's on the 0 axis, and this is 1, negative 0.5, and this is 2, negative 1. And then we connect with a line to show the curve of the graph. There are 3 ways to evaluate e to the x using a calculator. The first method is to use the e to the x key on the calculator. The second method is to use the graph of y equals e to the x. And the third method is to use the table of values for y equals e to the x. Continuously compounded interest. The example we'll be using is Sarah invests $1,000 at an annual interest rate of 5%, compounded continuously. Calculate the final amount she will have in the account after 5 years. So the formula we'll use is A equals P times E to the RT, where A equals the total amount, P is equal to the principal, E is the mathematical constant, R is the rate of interest, and T is the time in years. So we'll find each of these variables in the equation and plug them into the formula. So for P, the principal is $1,000. Then E stays the same, and then R, the rate, is 5%, and the time in years is 5 years. So we plug this in and we have A equals 1,000 times E to the 0.05 times 5, which would equal A 1,000 times E to the 0.025, which would equal $1,284 and 0.02 cents. Writing exponential equations in logarithmic form. If y equals b to the x, then x equals log b times y. An example of this is write the equation 2 to the 5th equals 32 in logarithmic form. To do this, you would move 2 to the other side and make it the base of log, and 5 would remain on the other side, and then 32 would stay on this side. Evaluating a logarithm. When evaluating a logarithm, one would move the base of the logarithm to the right-hand side of the equation and make the term that was already on that side the exponent of the new term, and then the term that was on the left side with the log and its base will remain the same. Using a logarithmic scale. When using a logarithmic scale, adding 10 to negative 20 or to 10 will increase the value in a positive manner, and subtracting 10 from 10 or from negative 10 will decrease the value in a negative manner. And this goes for any area, so you could subtract negative 10 from negative 5 and you would have negative 15. And the same goes for over here. And then when using multiplication or division on the logarithmic scale, multiplying 1 by 10 would give you 10, and multiplying 10 by 10 would give you 100. Oops. And then when dividing by 10, dividing 10 by 10 would give you 1, and dividing 100 by 10 would also give you 10.